So, if you've spent any time with an AI coding assistant, you know they're pretty good, right? Spotting errors, generating boilerplate.
Yeah, they're useful for that static stuff.
But there's always been this fundamental limit. The AI couldn't actually see what its code did.
Exactly. It was coding blindfolded, basically.
Yeah.
Couldn't see the render, couldn't click anything.
Couldn't even check if its own fix, worked in the browser by looking at network requests.
Well, that era, it's over now.
Okay.
Yeah, our deep dive today is all about the Chrome DevTools MCP Model Context Protocol. And this isn't just some small update.
Sounds like a big deal.
It is. This is basically the moment AI coding agents get eyes inside a live Chrome browser. They go from just suggesting code to being active debuggers. Clues in the loop.
Okay, that is a huge shift. So we need to unpack this. Two things, right?
Right.
First, what's this MCP standard underneath it all? And second, how does the Chrome DevTools part give the AI, well, our familiar developer toolbox?
Exactly. And the timing's key, too. This wasn't some quiet release.
Yeah.
The Chrome team announced the public preview September 25th, 2025.
Okay.
And boom, suddenly you could connect AI agents like Cursor, Claude Code, Gemini CLI, the ones people are using, directly to a real browser automation. Powerful stuff. So to really get it, we got to start with that standard, the MCP.
Right, let's tackle MCP first. Model Context Protocol. The note's called the Universal Adapter Plug for AI. Why that? Why not just build custom APIs for every tool? Seems easier, maybe.
Well, easier short term, maybe, but custom APIs create silos. MCP, which Anthropic pioneered back in late 2024, it's an open standard.
Okay.
Its whole purpose is to solve that communication mess. It defines one consistent way for these large language models.
The LLM?
Yeah, the LLMs, to talk to any external service or tool. Before MCP, connecting an AI to a database needed one protocol, connecting to Slack needed another. Messy.
Ah, so MCP standardizes that connection, that handshake. Okay, I see the decoupling benefit now. It splits things up.
Precisely. You get two clear rules. Developers can build or just use MCP servers. These servers expose some function, a database maybe, or like here, a browser.
Okay.
And then the AI clients, the coding assistants you use, they just plug into those servers. They speak the same MCP language.
So the server's the socket, and Chrome DevTools MCP is just a really powerful device plugging into that socket.
You got it. And the big goal here for you listening is moving past these isolated kind of blind AI models towards what we call context-aware AI. AI that can actually go get information, interact with real systems. Google's Chrome DevTools MCP is their big contribution, their specialized server for this ecosystem.
Okay, which brings us to the tool itself, Chrome DevTools MCP. It's that specific server exposing all of Chrome's debugging power to the AI, the bridge to a real browser.
Sophisticated bridge, yeah.
But hang on, controlling a web page dynamically?
That's tricky, right? Stuff loads late, elements aren't ready, the server can't just be firing off raw commands, can it? It needs to be reliable? Absolutely. And reliability is probably the key differentiator here. Under the hood, yes, it uses the low-level Chrome DevTools protocol, CDP.
That's the native debugger interface DevTools itself uses.
Exactly. But, and this is crucial for robustness, it doesn't just sling raw CDP commands. It uses Puppeteer.
Ah, Puppeteer. The Node.js automation library, battle-tested.
It's the safety net. Puppeteer handles all that messy asynchronous stuff automatically, waiting for pages to load, waiting for the DOM to be ready, network idle.
Right, all those waits you'd normally code yourself.
Yeah, so when the AI says, click this button, Puppeteer makes sure it happens reliably, like a proper automation script would, not just firing and hoping.
And the AI client, the assistant, it never actually sees Puppeteer code?
Nope. It calls a high-level MCP tool, something simple like navigate page.
Okay.
The MCP server does the translation, runs the Puppeteer CDP stuff, and then sends back the results. Usually structured JSON the AI can understand easily.
That abstraction makes sense. How does it run? Like on my machine?
Yep, runs locally. It's distributed as an NPM package, so pretty easy to get going. And secure, they thought about that.
Yeah.
By default, it uses a separate, isolated Chrome user data directory.
Yeah.
So your personal bookmarks, history, logins, they're safe. Or you can use an isolated flag for a completely temporary profile.
So the AI's automation is sandboxed away from my stuff.
Exactly. Keeps things clean and safe.
Okay, so we have the secure, reliable bridge. The AI can talk to the browser. Now, what can it actually do? How does it stop just suggesting code and start, well, doing a developer's job? What's in this toolbox?
It's basically the toolbox you use every day in DevTools. The AI gets programmatic access to the elements panel, network, performance, all of it.
Seriously, the whole suite.
Pretty much. Let's break down the categories because the range is really something.
Okay, hit me with the most obvious win first.
User interaction simulation. This is huge.
Oh.
The AI can now run through complex user flows. Tools like click, fill form, hover, even upload file. So think about the AI simulating logging into a site, filling out a whole multi-step checkout form, clicking submit, testing that whole journey.
Whoa. Okay, that alone is game-changing. What about seeing the visual stuff? Layout bugs?
Right, DOM inspection and scripting. It can run JavaScript with evaluate script, check the console with list console messages. But the real kicker, taking a DOM snapshot, take snapshot.
A snapshot of the structure.
Yeah, or even a visual screenshot. Take screenshot. This gives the AI the structural and visual data. It can finally see the rendered page to figure out why things look wrong.
Okay, needed that. Now, what about those bugs that only show up, when it actually runs? Network problems.
That's where network inspection comes in, total detective work. The AI can use list network requests.
See all the requests?
See everything. Get details on specific ones. Did an image 404? Is an API call super slow? Is there a sneaky CORS error blocking something? It checks the headers, the console. It finds the evidence. No more guessing.
That's incredibly useful. Okay, the other big one mentioned was performance.
Yeah, this turns the AI into like a performance consultant. You can run a full trace using performance start trace and stop.
Like the performance tab.
Exactly. But even cooler is Performance Analyze Insight. This tool automatically pulls out key metrics. It can calculate Largest Contentful Paint, LCP.
The main core web vital for loading speed.
Right. So the AI can basically run an automated lighthouse audit for you.
Wow. Okay. And the last category, emulation?
Emulation, yep. The AI can toggle different conditions. Emulate TechPoo to throttle performance, emulate network for slow 3G.
Oh, nice.
Or just resize the viewport to test mobile layouts. Great for catching those works on my machine bugs that only happen under specific constraints.
Okay, that toolbox is seriously comprehensive. Let's pivot then. How does this actually change my workflow? What are the aha moments?
The biggest one, real-time verification, that closing the loop thing, meaning the AI suggests a fix for, say, a layout bug. Then it can immediately spin up Chrome, apply the fix, load the page, take a snapshot or run a quick check, and confirm it worked.
Ah, so it tests its own work. Less guesswork.
Way less guesswork. It catches things that look right in the code but break visually or functionally.
That naturally leads to better diagnosing runtime issues, like your image example.
Exactly. Before, the AI might just say, check the path. Now, it navigates, runs list network requests, sees the 404, or checks list console messages, finds the CORS error.
And suggests a fix based on that specific error.
Right. Image is failing due to CORS. You need to adjust your server headers, like this. It's evidence-based debugging.
Which also makes it useful for testing, I imagine.
Definitely. Automated QA testing.
Yeah.
The AI can simulate those complex user flows we talked about, log in, fill form, submit, while actively watching the console.
Catching silent errors.
Yeah, maybe a JavaScript error happens during form submission that doesn't stop the user immediately but breaks something later. The AI spots it, finds the line number, suggests the fix.
Okay, I can see that saving a ton of time. And for visual stuff, like CSS bugs, you mentioned snapshots.
That's virtual front-end debugging. If you tell the AI, hey, these elements are overflowing on mobile, it can resize the viewport, use take snapshot.
Analyze the live DOM structure.
Exactly. And the current CSS. It might see, this container has height 300px, but the content needs more space, and it'll recommend the fix. Add overflow .auto to the .myContainer class. It's inspecting the live result, just like you would, but programmatically.
Man, that hits close to home. And the performance part. It's not just suggesting general tips anymore.
No more guessing. Proactive performance audits. You can literally say, localhost 0.8080 is slow. Make it faster.
And
it runs the performance trace, uses Performance Analyze Insight, maybe finds the LCP is delayed by a huge hero image.
Okay.
Then it proposes targeted improvements based on that measurement. This 2-meme JPEG is blocking render. Try converting it to WebP and resizing it. It's measuring, diagnosing, then fixing.
That's a huge leap from just static analysis. And beyond pure debugging, there were some creative examples too.
Oh yeah, the automation potential is wild. Dilip Rao showed the AI using the Gemini CLI to control Chrome.
What did it do?
It opened Google Scholar, searched for a specific term, found the top 5 results, and downloaded the PDFs. All automated browser action.
Wow, okay. Research assistant.
And Guntram Bechtold did that fun one asking the AI via natural language to apply CSS chaos to Hacker News.
CSS chaos?
Yeah, like make all text Comic Sans, add rainbow gradients, glowing borders. The AI used its DevTools access to inject the CSS and make it happen. Just shows the level of control.
Okay, this really is a paradigm shift then. The AI isn't just writing code in isolation. It's in the browser, debugging, testing, optimizing, interacting.
Yeah, I like the analogy someone used. It's like giving the AI an intern who can actually run the code and test it, not just write it down.
Leads to much higher confidence in the results, I bet.
Absolutely.
So for anyone listening who's thinking, okay, I want to try this, how do they get started? Sounds complex.
Actually, they made it pretty straightforward. You need Node.js, version 22 or higher, and a recent Chrome install.
Standard dev stuff.
Right. And it's an NPM package. So you basically just configure your AI client, Cursor, Gemini, CLI, whatever supports MCP, to launch the MCP server using npx. The command is something like npx chrome DevTools MCP at latest. Pretty simple.
And it's still a public preview, you said?
Yeah, being built incrementally, which is good, actually. It means if you try it and think, man, I wish it had a tool for deeper CSS profiling, or I need more DOM commands.
You give feedback.
Exactly. The team's actively looking for that feedback on GitHub to decide what tools to build next. It's a chance to shape it.
Okay, good to know. So wrapping up, this tech basically unlocks the full power of the browser, all of DevTools for AI agents.
Right. They can control, debug, test the web autonomously now. Which leads to a pretty interesting thought.
Go on.
What happens when you combine this capability, the browser control, with other MCP servers? For GitHub, maybe? Or Slack?
Or?
Databases.
Connecting different tools together through the AI.
Yeah. So the final question for you to think about is this. If AI can handle the code changes and the interactive browser testing and debugging, does that mean complex workflows become entirely executable via natural language?
Making the human role just high-level guidance, steering the AI?
Could be. The age of context-aware AI, the AI that can see and interact, it's definitely here. Lots to mull over.